Okay, first day of Unit 5. We're going to kick it off by looking at section 4.5. So I get this was from chapter 4, but it totally makes sense to put it in Unit 5 because it's about integration. Here's a method that we're going to look at called U-sub, U-substitution, U-sub for short. But first, let's start by reviewing some derivatives. First one, let's say we're asked to take the derivative of tangent of e to the 4x squared. Okay, so when we take this derivative, this is definitely chain rule because we have this inside stuff. So the derivative of tangent is secant squared. So you get secant squared, okay, and the inside stuff is just along for the ride, so e to the 4x squared. Okay, now chain rule says that stuff that was just along for the ride, we now have to take its derivative. So if you remember, the derivative of e to any power is you copy that over. Then we have a second chain rule because now we have to take the derivative of that, which is 8x. Okay, so here's the derivative of tangent e to the 4x squared. We could probably write it a little nicer, right? We could write 8x e to the 4x squared, secant squared of e to the 4x squared. Any way you write it, this looks pretty messy. Okay, let's go on to 2. Now we're asked to integrate. Well, we have never integrated something this difficult before. Okay, and what makes this one so difficult is there's so many x's that cannot be multiplied, right? Like we've talked before, if you had x's multiplied or divided, you have to simplify it. So we had them split out. So like if we had x squared plus 8, we could distribute and get x cubed plus 8x, then we could integrate, right? But something like this, there's no way that we can multiply those. So what's going on here? There's a quick way that you can actually find this answer. Why don't you pause the video, take a second and look for it. Don't know if you realized it, but look, it's exactly this. So if I took, the only way right now that we know how to do this is if I took the derivative and got here going this way, then to go backwards, I would integrate this stuff to go here. So we know now that if I integrate 8x e to the 4x squared, secant squared of e to the 4x squared, I'm going to get tangent of e to the 4x squared. And do you notice a mistake? Plus c, good. So the only way we can integrate this crazy stuff if we know that it's somebody's derivative. And there's no way that they're going to give that to us all the time. Okay, if we did not do example 1, we could not have done example 2. Also, just to point out, this was a big uh-oh, like I said, because there's no product rule. The best way to be prepared for this section is really going through the problems, because then you'll start seeing patterns and how to use U-sub. So just keep in mind, if it's a little tricky in the beginning, it's going to get better. Okay, so again, I'll let you read through these paragraphs as always as you're studying or reviewing in preparation for your homework. But I just want to remind you this is a composite function where this is the inside, right? So we take the derivative of the inside and then we take the derivative of that inside, and we referred to it earlier as like unpacking boxes, right? Now we're going backwards. Now look, the boxes were unpacked here, but then when we went backwards and integrated, look how nice and tidy everything looks. Okay, so that's what we're going to look for. Chain rule, again, if we're looking at, this is what we saw back at probably section 2.4. This is the inside function. So if you remember, you take the derivative of the outside, give you f prime, copying over the inside, and then you multiply by the derivative of the inside. That's chain rule. Now, just like I showed you up above, we're going backwards. Now we're going to integrate this piece to end up here, which is what we have. Okay, a fancy way to write this is in this box here. Remember, everything in boxes are important. And they tell you that capital F is the antiderivative of little f. So if I integrate little f of g, and g derivative is in the problem, I'm going to end up with capital F, and once again, g's along for the ride. There's another way to write this that kind of corresponds. You're probably thinking, why is she calling it U-sub? We haven't seen U yet. Let's let U be the inside stuff, which is g of x. That means the derivative of u with respect to x is going to be g prime. Now we're going to write it a little differently, and instead of writing du dx, let's move the dx to the other side so that du is g prime of x dx. We can use this to simplify the integral by replacing the g of x with u, and then g prime of x dx. Do you guys see this? Let me highlight this for you. So I wrote f and I replaced g with u, and then g prime x dx we can replace with du. So what we did is we took this messy looking thing up above, and by using u substitution we were able to clean it up. They told us up above that capital F is the antiderivative of little f. So if I integrate little f, this is just like backwards chain rule is how I would think of it, then you're going to go ahead and get capital F, remember g was u, capital F of u plus c. Remember, math is case sensitive, guys. Make sure you're writing little f and capital F. Okay, I mentioned this earlier. The best way to get good at these is practice, looking for patterns. This might seem, like I said, a little challenging at first. You're going to be awesome at this. Look at 3A. When you're doing these problems, remember they're not going to say on the EP test, hey guys, this is from USub, right? You have to know to use it. So looking at 3A, how would you know to use USub here? First things, can you expand? Can you distribute? Nope, because this radical is here. So because of that, we're going to think USub. Because we're dealing with f of g of x, right? We're dealing with composite functions. G is going to be the inside. The inside stuff is normally like under the radical or in parentheses. And if you look up here, u is the g, which is the inside stuff. So take a guess. What do you think this inside stuff is I'm referring to? It's going to be normally the stuff in the parentheses or under the radical, which is x cubed plus 1. You can see that right here. Okay, that means du, remember we moved the dx to the other side, so let's just do it right away. We're going to get 3x squared dx. This is like your translation code. This should be enough for you to be able to do the problem. So another clue that you want to look for is whatever the u is, that derivative should be in the problem. The derivative of x cubed is 3x squared. We don't care about the 3, but I care about the x squared. Okay, now we're ready to rewrite the problem. I want you to replace u first. So because u is x cubed plus 1, this becomes the square root of u. The x cubed plus 1 got replaced with u. Now look what's left. I'm going to go ahead and cross that out. I'm left now with an x squared and a dx. Do you guys see x squared and dx right there? So how could I get them by itself? Do you see that we could divide both sides by 3? So 1/3 du is going to be x squared dx. So this x squared dx up above, I'm going to replace with 1/3 du. My goal is to get rid of all of the x's and replace them with u's. Look at how much nicer this looks. Okay, I went ahead and started rewriting it out so it's calculus friendly. Now we can integrate this. If you add 1, we're going to get u to the 3/2 times 2/3 plus c. At this point, we're almost done, but do you see a u in the question? There's not. So we have to replace u with what it was. If you look up above, we let u be x cubed plus 1, and we should be good to go. Okay, there's our answer. Now, just to confirm, if I check this, like if I take the derivative of what I just found, I should end up where I started. Let's check it real quick. So if I take the derivative of 2/9 x cubed plus 1 to the 3/2 plus c, the 2/9 stays, the 3/2 comes down, I rewrite the inside stuff, I decrease my power by 1, and I multiply the derivative of the inside, which is 3x squared. If I clean this up, let's see, the 2's cancel, 3 times 3 is 9, over 9 is 1, and then I have x squared, x cubed plus 1 to the 1/2, which, ta-da, that's exactly what we started with. How do we know? You can look back up here, right here. That's exactly what we started with. So we took this integrated and got here, and then I went backwards and I took this derivative and got where I started. Okay, so quick way to check on your test. Okay, going on to B. First question, is this u sub? Well, could we divide it out? No, we can't. So it has to be. U is going to be the inside stuff, almost always, the stuff in the parentheses. A quick way to know if that's your u is when you take its derivative, do you end up with the other x's? So look at, this is my u right here. Right, that 16 minus x to the 8th was my u. When I took its derivative, I get an x to the 7th, which is right there. So I'm good. Okay, let me erase that so you can see the problem. That's confirmation that we're on the right track. Our goal is to get rid of x's, replace them with a simpler u, and then we'll swap back at the end. So let's start writing our integral. U goes on the bottom and it's squared. I have an x to the 7th dx left I have to get rid of. So I want to isolate that. In order to do that, I'm going to divide both sides by -1/8 or by -8. So I'm going to get -1/8 du is x to the 7th. Oh, did you guys catch that mistake? That's supposed to be a dx. Okay, x to the 7th dx. Now that I have that, I can go to the problem and I had x to the 7th dx that I have to replace. X to the 7th dx is negative 1/8 du. Negative 1/8 du. So much better. Negative 1/8, the integral of u to the negative 2 du is going to be negative 1/8. Let's add 1, u to the negative 1 over negative 1 plus c. Clean it up, 1 over 8 u plus c. We can't have u's. They didn't have u's. So now we have 1 over 8. U is 16 minus x to the 8th plus c. Awesome. I'm not going to check this. If you want to, go ahead. Okay, on to c. What's the first question we've been asking? Do we even need u sub? Take a second, think about it. We don't. We can split this up. You can break the radical out. So this is like if I had the square root of 9x, right? Wouldn't this be 3 root x? So I don't know the square root of 5, but I'm going to write it out in front. And then what's left? I'm going to have the integral of 1 over root x dx. Now we can do this, right? We couldn't do it with the 5 there. We don't know how to integrate that. We only know an x to a power, right? Not when, because what that really is 5x to the half, and we don't know how to do that. But we can totally do it if it's just x to the half. So that was our goal. So now we're going to rewrite this as x to the negative 1/2 dx. So 1 over root 5. If we add 1, we get x to the half times 2 plus c. No reason to replace anything because we didn't even use u sub. So 2 over root 5 times root x plus c. Okay, we would be done. But it's in this section, so can we use u sub? Let's double check. What could u be? Remember, u is normally the stuff in the parentheses or under the radical. So if u is 5x, du is 5 dx. Let's write a big or here, right? Because we're thinking there's another way to do this. If I replace it, I'm going to get root u on the bottom because, again, look, u is 5x. So this gets replaced with a u. Now so this is gone. Let me cross it off. I think I've been using green. That's gone. Now I need to replace dx. So I'm going to go over here to the second line, and I'm going to divide both sides by 5 so that I just have dx. Okay, and just before we forget, this was 1 over root u. Okay, so I went ahead and wrote this out. 1 over root u, replaced all this. Dx was 1/5 du, 1/5 du. Okay, now we can integrate this. It's 1 over 5, the integral of u to the negative half du. If you add 1, you get u to the half, divided by a half is times 2 plus c. So now I have 2 over 5 root 5x plus c. Now, if we did it 2 different ways, we should get the same answer, and they're not. So let's see what we can do. Look on the left. What could we do to make the left look like the right? Couldn't we rationalize by multiplying by everything by root 5? By everything, I mean numerator and denominator. And then look, we can merge both things and put them both under the radical. So then I'm going to get 2 root 5x over 5 plus c. Woo, we're lucky they worked out. Okay, going on to D. Do we need u sub? Please don't assume everything needs u sub. There's multiplication, but do we need to use u sub? Well, let's look up above to see when we were using it before. These had multiplication, right? This was being multiplied, but we couldn't distribute because of this barrier. This had division, right? But we couldn't divide because we had multiple terms on the bottom. The u was always the stuff in the parentheses. Go down here now. Look, there's no barrier on this. There's no power here. We can totally distribute that y. We do not need u sub. We are not going to fall for that trap. 2 pi is a scalar. Write it out in front. Then we get 8y minus y to the 5/2 dy. Go ahead and integrate. 8y squared over 2 is 4y squared. Minus, if you add 2 to 5/2, you get 7/2. Instead of dividing by 7/2, multiply by 2/7 plus c. And I say we're done. Okie doke. We're all set here. First day of u sub. I hope you guys have a great day, and we're under 15 minutes. Awesome. See you later.